Alright folks, this is Eric from Kansas again. So we made it to our mom's house, or sorry, my mom's house, and we are getting ready to install this generator transfer switch. And so this is install day number 1. So here's the transfer switch out of the box, and here's the breaker box we're going to be putting it next to. It's a 200 amp, I think it's a 40 position box there. So I'm going to put it right here and get that mounted and hooked up to the switches she wants it hooked up to, and then we're going to start figuring out how to wire it from, or supply the power to it. And there's a bedroom on the other side of this concrete wall, so I'm going to hopefully go through this wall here, and this is so there's the kitchen's right behind this wall here, and then there's obviously a floor, and then below that's the bedroom. So still figuring out how I'm going to get through here and down the bedroom, but I definitely don't want to drill through this concrete wall. So that's what I'm figuring out right now, but I'm going to get this transfer switch mounted, and then we'll catch back with you later. Alright folks, I actually took this transfer switch box apart a little bit. So you can see I've got a couple of lower mounting holes right here, and one right here I'm going to use. And then the upper ones are up here outside the box. But I went ahead and took this apart a little bit so you can see what's inside. See, it's pretty well organized down below here for the power coming into the circuit breakers. And then just so you can see on the back of these, there's no power obviously, so I'm trying to do this one-handed. But so you can see inside here, it's pretty nicely organized and laid out, good connections. See if I can focus there, sorry. There's the watt meter in the foreground, and that's the transfer switch connections there. So just a bunch of switches and wires, and then we got the L5 30 amp plug here for 125 volts, which is what I wanted. And yeah, so that's that. I'll continue on. Alright folks, so we got the transfer switch box mounted, and it's got the wires dangling there, and we're going to come up through this spot in the breaker box. This is kind of an odd breaker box, and that's embedded in the wall, but just the way I did it. But we're going to come up through this 3/4 inch hole I punched out, and here's the conduit piece that came with the box, which is pretty handy, and they got the little plastic inserts on both ends of it to protect the wires from the metal. And on the bottom they have this elbow. I can't remember the exact name of these, but got this elbow joint. So what this thing is going to do, this conduit, you're going to run all this, run this wire through it that's dangling here, and we're going to come up to this elbow joint, and then this conduit fits up against the elbow here, and the wires will be going into this tube, so they won't be dangling there anymore. And they give you this cover for the bottom of it that just, there's a hook point right back here where this little hook grabs onto, and then there's 2 screw holes, and those go into those holes right there, and that's how it protects the wires coming out of the transfer switch box. On the other end, the end of this that goes into the box, they give you 2 options. You can either use another elbow like this, exactly like the one that was right under here on this box, or they give you one of these so you can just go straight in. That's what I've chosen to do, because if you do the other way, then this transfer switch box would have to be farther that way, and I don't have a lot of room that way. Since I don't want to cut this, just want to use it all. So I'm going to come up here straight with this conduit fitting here. It's got this little nut here, goes up here, and you twist it on, and when you put it in there, that holds it in the box. It's going to sit like this. And these fittings, instead of there being a, you can see this little divot here in this bottom of this elbow, little divot there. That's what holds, gently holds this conduit from slipping out of this joint. And I think there's another indentation up in here too to hold the conduit in there. The way the conduit is held in with these street pieces is there's a, you can see it in there. There's a thread, a single thread right in there. And that just twists on to this conduit. If I can do it one-handed here. You just put it on here, and it just screws onto the flex conduit. And then you use this screw to just kind of tighten it up when you put it in there to make sure it holds in there. So anyway, we get this all set up here and we'll continue on. All right, almost got this wired into the box and ready to pick out circuits to wire it into, but I wanted to show you this tip. And before I get there, I'm not gonna lie folks, this is you can see this right here. You'll see it in a minute here after I get it all installed, but I'm not gonna lie, this is a tight fit. This conduit is completely full. So if you need to rewire anything in there, you're gonna have to take it all back apart. So one tip I want to, when you do this, if you do this yourself, this nut that goes on to whatever fitting you're putting on here, make sure you take it off before you try and put this thing up in here. Otherwise, if you get these wires all threaded through this hole, which is no small feat, and you still have this nut on there, you're gonna have to take them all out again to get this nut off and back around the wires. So make sure this nut off before you thread the wires through here. So now I'm gonna thread the wires to this nut and get this fitting mounted on this box, and we'll continue on. All right, I got this all in here. I'm going to tighten this screw up here on the fitting down below. Get that a little snug to not be too tight. And then I'm going to take a standard screwdriver and tighten up this nut down here a little bit. Yeah, it's pretty tight. Okay, I think that's good enough. Now, on to the more fun part of trying to organize these wires. So if you watched some of my previous videos on transfer switches, the generator transfer switches, these wires, see if I can get some light in here. These wires are lettered. So you can see this black one here. It's got the letter D on it. D, 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 all on the wire there. This one right here has the letter, focus, F on it. F, 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 all on the wire. At least on this part of the wire anyway. So, got a D and an F wire right there. So if I go back over here, look at what we have here. We have letter D, letter F, and the rest of the wires are A, B, C, and E. So these wires that are lettered match up with the switches here, or sorry, the transfer switches here. So one wire comes from, one wire grabs the wire that goes to the house and connects it up to this box. The other wire, I think might be the red wire, I'm not sure. The other red wire of that circuit connects up to your circuit breaker. So the circuit breaker is what provides the hot leg. You run the hot leg through the red or the black wire through this box into this transfer switch, and then the other, the black or red wire, the other one you're using, completes the circuit, comes back out through here, and goes to the house. So that's how that works. And then we've got one single neutral wire here and one single ground wire here, green and white. And those go up to your neutral and ground bars. And the thing I wanted to mention, I think I mentioned this in a previous video, for this box and for all the boxes that I think Reliance Controls make. So all these wires are 10 gauge, which is really nice. So they'll handle up to a 30 amp circuit, which unless, so they'll handle up to maybe a water heater or something like that, or let's see, what's this? Oh yeah, I guess this 30 amp circuit is a dryer for this house. We have some 40 amp 220 volt circuits here. I won't be powering anything with 220 volt. That's not what I'm doing here, but I got some 40 amp circuits here for some ovens and some cooktops, and the AC for the house. So these will power anything up to a 30 amp circuit, 220 volt or 120 volt, which is nice. So I'm going to get these wired up, and then I'll show you some progress. All right, folks, so it took us a little while to figure out what circuits we wanted to power. I had to do some more troubleshooting and find out what was what. Took a little more time than we thought. It's nighttime out now, unfortunately, but got this part of the project done. So this transfer switch is, if this is all you're going to do, this is fully installed now. Just got to put the breaker panel cover back on. And so got all 6 circuits hooked up. So let's see. Circuit A is kitchen fridge, and it's also got some other stuff on it that not supposed to be on there, but that's what happens when you get a kitchen remodel. Let's see, no, sorry. A is garage doors and garage lights and some other stuff. B is the garage outlets. Let's see, C is an office where we have some internet equipment. Definitely want that during a power outage, along with the garage doors and whatnot. Let's see, D is the kitchen fridge. Definitely want that one. E is going to be the master bedroom and bath. It's an important one during a power outage. And then the last one, F, is the furnace. So that's going to power the furnace. It doesn't power the air conditioning condensing unit. For those of you that aren't familiar with how the air conditioners in most residential houses work for the U.S., the furnace is powered by a 120 volt circuit, and the AC condensing unit is typically powered by a 240 volt circuit. So this F just powers the furnace fan and all the electronics to control temperature, and so that will allow the house to at least have heat in the wintertime, assuming this house still has natural gas supply during a power outage. So that's the circuits I've got installed here. And also wanted to mention, I mentioned earlier, these are a lot of the wires that, most of the wires that are circuits I hooked up to are on the left hand side here, so that's where most of the wiring went to. And then one on this side. That was the furnace, and then on this breaker panel, the ground wires and the neutral wires are both hooked into the same bus bars. So that's what I've done here. Here's the ground wire, and here's the neutral wire. Another thing I wanted to mention was I thought all these wires were 10 gauge wires, and they're actually not. Circuits A and B are 10 gauge wires, and the rest of them are 12. So you still could have 20 amp circuits here if you wanted to, and actually some of these circuits do have 12 gauge wiring on them, so I could put a 20 amp circuit on here, and I might do that later on. But A and B could have 30 amp circuits on them if you wanted to, since they're 10 gauge. And then the neutral wire here is also a 10 gauge, but the ground wire is a 12 gauge. So that's what we got there for wire gauges. So if you put these together in the future by yourself, or even if you have an electrician do it, make sure they know that some of these wires they're not all the same wire gauge. So make sure that they pay attention to that when they're installing them, and to what the breaker reading is on here, and and what the breaker reading is on your transfer switch box. All right, so that completes the transfer switch install portion of this project. Hope you got something out of that, and I'm going to move on to the next part of the project, but I think I'm going to post this as its own video as well, just so that part's a little more condensed. So hope you enjoyed that. If you have any questions or comments, let me know, and grace and peace be with you. Bye for now. All right, everyone, so we're on to the next phase of this install. So this morning I went ahead and wired up this line right here, which is the AC power supply to the inverter charger, and I didn't get the transfer switch I got planned here. It's a bigger box, which is a single transfer switch in it. I'm going to use to make it so that you can charge the batteries of the generator if we need to. So that's the reason for the extra transfer switch. But I'm using this box as a proxy for right now. I'm just going to join some wires in there and then run some more wires back this way. And one of those wires is sticking on the wall here, this longer orange one. That's going to go in this box right here. So this is the AC power supply to the inverter charger. Come back here and go back downstairs to the bedroom. And this shorter orange wire, 10 gauge wire, is going to connect up to the transfer switch box here, and that's the power supply, the power coming from the inverter charger. Whether it's through just the transfer switch in there, coming from grid power, or if the power goes out, it'll be coming from the batteries downstairs and going into this box. So we got this all wired up last night or yesterday, and now didn't take a video until now, but I wasn't sure I was going to route this wire exactly. But I got a hole in here, and I got a hole through some ceiling sheetrock that's going down in the bedroom down there, and I'll show you that in here in a second. All right, so here's the bedroom downstairs. This cabinet here, if you recall this thing, it's going to sit in here. It's going to sit back in the corner in here, and I already ran the wires through the ceiling here, and we're going to have both of them run into this box and connect to the inverter charger inside here. So I just got to figure out all this conduit here, but the wires are going to come through this this box here from the ceiling, and then we're going to have some rigid conduit going down most of the wall here, and then I'm going to have some metal flex conduit finish it off into this cabinet here. So that's the work so far today, and we will continue on. All right, everyone, so I got everything all pretty much all buttoned up here. on the garage side. So generator transfer switch box there. We got a temporary box here. There's gonna be another transfer switch box here, single transfer switch box for supplying generator power later on. So we got the AC input line coming in here on the bottom, and then the AC output from the inverter charger coming in on the top on this this wall over here, and going to the transfer switch box. And this conduit right here supplies the power to the circuits we wanted to power in here. And we're all looking good here. I might still have a big hole here. I might put some insulation in here, but yeah, use some conduit bodies, 3/4 inch conduit here. I actually have some. I had a lot of leftover 10-4 wire, so that's what I'm using in here. So it's handle 30 amps. And if you ever want to power something with 240 volts, there's an extra leg in there to do 240 instead of 120. But anyway, it's all 10-4 wire and all, or sorry, 10-3 wire and all this stuff, all this conduit. And then one more thing I want to show you was got the breaker installed here for the grid power supply to the inverter charger. It's a 30 amp 120 volt breaker. That supplies power to this conduit right here, this box, and then goes back downstairs. And so now I'm done up here. I'm going to go downstairs and we'll start working down there. But yeah, stay tuned. Okay, everyone, now we're downstairs doing a little work. Got this box installed I showed you earlier. Just ran the wire straight through. So the one on the right is the inverter charger output. On the left is the incoming grid power to charge batteries and or generator power. And we're going to come down here, down the wall, through some rigid conduit a little bit, and then we're going to switch to some metal flex conduit and get down closer here. And we're going to come in the side of this cabinet here, and I think I was originally going to have flex conduit all inside here, but I think I'm just going to have this bare, well, not bare wire, but bare Romex 10-3 cable in here since it's enclosed, and just going to have it kind of run along the back maybe a little bit, and then it's going to come in this side of the inverter charger. So that's where I'm at right now, and I'll update you when I get a little further. Alright, so I thought I'd do another update here before I finish this project up here, and I did some more testing, but I put the cover back on there. But so this is the AC input and output wires coming down to this cabinet from the garage, and just about to got them all stripped, and I'm just about to get them connected up to the terminal block back in there. Sorry, my phone's in the way of the light. So right now I got the AC input power on, so this guy is hot right here, and I'm going to measure the voltage, make sure it's the AC input and not the output, because that would be bad if I switched them up. So I'm going to make sure I got the right connections there, and then turn that back off and button it all up, and then I'm going to do some testing, and we'll see how that goes. Alright, everyone, so the install is finished. This system operates with flying colors, everything we want it to, and got a couple of bonus things that are powered in the house that we didn't know were powered from some circuits that we powered, so it's always a plus. So this thing is, we just got done testing this thing out with a simulated power outage. We shut off the power to the house and saw make sure everything worked, and it did. So we got the garage doors powered. We got the TV powered, which was a surprise. Got some outlets in the garage and some outlets other places in the house, so we can keep internet power and things. And we got a refrigerator. We got a furnace that's powered, so we can have heat. Not the air conditioning part though, just so the furnace fan runs. And let's see, a few odds and ends of the house I showed you earlier, but yeah, they all worked. I left this thing fully closed up overnight, just allowing power to pass through it on the ready in case power went out. And did get a little warm inside the cabinet, so I'm just going to leave this open a little bit for now, like that. And think about where I want to put some ventilation holes when I come back here at a later time. And still thought to put in the generator input plug and transfer switch I wasn't able to get installed since I didn't have the part on in time. But everything else is working and installed. So yeah, that's how I came into the cabinet with the input and output AC lines, and just didn't run it through Conduit, which is a good thing, because getting this box installed was it's pretty tight inside this little box they give you with the inverter charger. It looks like there's a lot of space in there, but when you're messing with 10 gauge wire, it's pretty stiff. It makes it kind of hard. So it's all working pretty good. And I think I'll go upstairs and show you the final install there, even though I think I already did, but just to make sure I run out the project in video here. So I'm going to go upstairs and we'll run out the video there. Alright everyone, so that rounds out the install here. So here's the upstairs portion. Already seen a little bit before, but I'll show it to you again here at the end. Again, this box is temporary. Let me put another transfer switch box there so that we can switch between grid power and generator power to charge the batteries. I'm going to use the plug that we got from this guy. That's why there's a hole there. Use the plug and put it in a box and mount it outside on the other side of this wall, and so we can have generator power if we need it. But yeah, I think that's all I want. Also, I wanted to mention here, we got this box labeled here, so you can see what it powered, and we got this breaker labeled up here. There we go. Finishing touches activities there, but that's about it. I may make another video on installing this transfer switch box over here, but other than that, we're done. The client is happy, and let me know if you have any questions and comments, and we'll talk to you later. Bye for now. Grace and peace be with you.